In this tutorial video, we will be talking about how gases behave. So we're going to be looking at a couple of different concepts. So first of all, we'll be looking at diffusion. Then we're going to be looking at air pressure. And then we're going to try and use our understanding of air pressure to explain two different demonstrations that you've seen, the crushing can and the magic egg. Throughout the video, remember to use the pause button if you need to pause and think about what we've been saying. Make summary notes as we go through and bring any questions you have to the next lesson. So hopefully you've been able to have a go with the diffusion app from PhET, which is a really nice tool to let us visualise what the gas particles are doing in diffusion. But before we sort of talk about a situation involving diffusion, let's have a look at this little video clip and think about the motion of the particles in the gas. And what we're looking to sort of pick out is this idea that if you're going to try and describe what the particles are doing, how they're moving, we would say that they're in constant motion and they're in random motion. So they're moving around randomly. They might collide with the walls of the container or another particle, and then that will cause them to change direction. But they're moving randomly and they're constantly moving. We've got two types of particle here. So one gas here and one gas here. And then at a point in the video, we're going to remove this divider between them, and then they will start to mix. So have a little look at what's happening. So you can see the particles are in constant random motion. We remove the divider, and then slowly the particles begin to fill the whole container, and the gas moves from one area across to the other area. And this is the process of diffusion, the gas spreading out from one area to another area, until we get to a point, as you can start to see here, where the gases are mixed. So this is a model to help us visualise the process of diffusion. But we have to keep going back to this idea that the gas particles are in constant random motion. So there are a couple of activities in your workbook asking you to think about what happens when you spray perfume in the corner of a room, to think about what's happening to the gas particles of the perfume. So look at this visualization and then think about what's going on with the perfume scenario. So next we're going to have a think about air pressure. You've probably heard about air pressure before, but now we're going to start to use our understanding of the different states of matter, of what the particles are doing in a gas, how they behave, to explain air pressure. So this is the air pressure demo, the gases intro from PhET, another lovely simulation, so do go and have a go with it. There's lots of different features on the simulation for you to investigate and play with. But what we're going to have a look at here is how the gas particles are moving in the container, and we're going to think about the collisions between the gas particles and the walls of the container. So we're going to add some gas particles into this container here. The gas particles spread out and they start to collide with each other and the walls of the container. And every time there is a collision between a gas particle and the wall of the container, the gas particle exerts a force on the wall of the container. And as we move through our science lessons, as we go higher up the school, we'll learn in the future that pressure is equal to force divided by area. So as these gas particles exert a force on the area of the container, they'll exert a pressure. Now what's interesting here is we can see that if we heat up the gas particles, they start moving quicker, and so there'll be more frequent collisions, and so the pressure will increase. If I cool down the gas, they start moving slower, there'll be fewer collisions, and so the pressure decreases. So the temperature of the gas can affect the pressure. If I make the container smaller, the area of the container has got smaller, so there are more frequent collisions between the particles and the wall, so the pressure has increased. If I make the container bigger, there are less frequent collisions between the gas particles and the walls of the container, so the pressure has decreased. And then finally, if I add more gas particles So if I increase the amount of gas in the container, there'll be more collisions, more frequently, and so the pressure increases again. If I take the lid off the container, then we get the diffusion situation again, where the gases in this container are diffusing away. And you can see that as the gas particles leave the container, the pressure in the container is dropping. So the more particles I have in the container, the more collisions there are with the surface of the container, so the higher the pressure. Now we're going to use these key ideas to explain the crushing can demo and the magic egg demo again. But what I would suggest is maybe pause the video now and go and have a go with the PhET simulation and investigate what happens when you add more particles, when you can measure how big the container is, you can measure how many collisions there are in a second in a certain amount of time, you can measure what happens to the pressure when you change the number of particles or the temperature of the particles or the size of the container. So go and have a play with the PhET simulation and then maybe continue on to the explanations, because this is our base understanding of air pressure, but now we need to use it to explain different scenarios. So we need to make sure we're really happy with these ideas before we move on to the next part. So we're ready now to try and explain the crushing can demo using our understanding of air pressure and how gases behave. So make sure you've watched the crushing can demo that was set with this video, and let's now have a little think. I'm using some basic illustrations and some particles. So we've got the can here with the hole where the ring pull is in the top. Here are the particles inside, and here's the heat source. So remember, at the beginning of the crushing can demo, we've put a small amount of water in the can and then we heat it up so that it forms steam. Now, we needed to heat the can up until we could see steam rising from the top of the can, until we could hear it boiling in the can. Okay, so here's the heat source. It's turned the liquid into a gas, and just as we saw previously on the PhET demo, we've heated up these gas particles so they're moving more quickly and they are escaping from the can. The reason that they're doing that is because they've been having more frequent collisions with the inside of the can, so the pressure inside the can is bigger than the pressure outside the can, so they're going out. And then the next step is that we turn the can over into the water. So if we have a think about what's happening now, when we've turned the can over, the key thing that happens isn't that the water is squashing the can at all, it's actually that the water blocks the hole. So this is where the hole would be for the ring pull. And as we turn the can over so that the hole is blocked, that means that no particles can go back into the container. This container is now sealed. It's like we've closed the lid on the container in the PhET demo. But because we had heated up the gas inside the container and the pressure had got higher and a lot of the particles had left, there's actually very few particles here now. So we've sealed off the container with very few particles in, and we've removed the heat source. So that means that the particles are going to start moving more slowly. They're going to have less frequent collisions, and the pressure inside the can is going to decrease. But remember, throughout all of these scenarios, and something that we couldn't necessarily see clearly in the PhET demo, was that actually this is all taking place in air. So there are gas particles all the way around this can, and they are exerting a pressure because they are colliding with the outside of the container. So we've now got a situation where the pressure inside the can is small, but the pressure outside the can is very big because of the collisions from air outside the container. And that then means that the pressure from outside the can cannot be balanced from the pressure by inside the can, and so the can is crushed from the outside air pressure. So have a little think about that explanation. You might want to rewind it and listen to it again, and then use these kind of notes, these ideas, to help you write your explanation in your class notes. We're going to use the fact-so structure, so we're going to write a scientific fact, and then we're going to say, so we observe this. So We might talk about the science facts might be things that we saw in the PhET demo about temperature increasing the speed of the particles or increasing the air pressure. We might talk about how the particles have left the can, so when they cool down there's a lower air pressure, things like that. It doesn't matter if this is not your best science explanation that you'll ever do. The more we practice, the better we'll get. What we're looking for is that you try and use the fact so structure to structure your explanation, and that you're having a go. So the next demonstration that hopefully you've seen is the magic egg demo. Now we're going to again use our understanding of how gases behave to try and explain the magic egg demo. So we have to think about what the gas is doing at each stage of the experiment, of the demonstration. So at the beginning we've got a conical flask and we put some water in it, and then we heated that water up and it started to boil and turn into a gas. And as that continued, because we were increasing the temperature, the particles were moving more quickly, so the pressure increased. That means that the pressure inside the flask is larger than the pressure outside the flask. So the gas particles are pushed out, and that means there are fewer particles inside the flask. We then put the egg on top of the hole in the top of the flask and remove the heat. So what this means is that no air particles can come in or out of the flask anymore because the hole is blocked by the egg. And because the heat is removed, the temperature of the gas is going to start to decrease. And we know from the work that we were doing on how gases behave, if the temperature decreases, then the particles will be moving slower, so there'll be less pressure on the walls of the container, and so the pressure inside the flask decreases. This then gives us the situation that we've got different pressures on different sides of the egg. So on this side of the egg here, there's a low pressure inside the flask, and on this side of the egg there is a high pressure from all the particles in the gas, in the air, whizzing around and colliding with the egg and exerting pressure on the top of the egg. This then results in the egg being pushed into the flask and squeezed through the narrow opening at the top, and then popping out the side, and then you've got the egg in the flask. So although it looks like there's a magic, secret, invisible force pushing the egg, actually what's going on is just that we've used our understanding of air pressure, how it changes with temperature, to push the egg into the flask. So there we have it. We've talked about the process of diffusion in terms of how gases are behaving, and air pressure, what's exerting pressure on the containers, how the particles are behaving in different situations. And then we've used those two concepts, and we've practiced applying them to different situations by explaining what we see going on. Now remember, with the explanations, this is a really important scientific skill, but definitely one that takes practice and time. So the explanations that we do right at the beginning, when we're learning science, will of course not be as good as the ones that we're doing by the time we get up to year 11 and upper 5, but the more we practice, the better we'll get. So make sure that you've made summary notes. If you've got any questions, bring them to the next lesson, and have a go at writing explanations to explain what's going on with the crushing can demo. And if that goes well and you're feeling confident, you can then have a go at the magic egg demo as well.